We're going to simplify some square roots. So on number 12, this one is probably one of the easier ones because there's not a regular number. There's exponents only. And you guys know that if an exponent, in order for it to be a perfect square, all it has to do is have an even power. So x to the 6, that's even. It's a perfect square. That can move out. Y to the 12th, the 12 is an even number. It can move out. So there's not even going to be anything left under this square root sign. The x to the 6th has a square root of x to the 3rd. The y to the 12th, when it moves out, has a square root of y to the 6th. Remember, when you take the square root of a letter, all you do is cut the exponent in half. So the 6 cut in half to a 3, the 12 cut in half to a 6. And again, this moved out and this moved out. There's nothing left on the inside. My answer is just x to the power of 3 times y to the power of 6. Now, on the next problem, I have numbers and letters. So the numbers work differently than the letters. In order to move numbers out, you have to divide it into perfect square factors. So you guys know that the number 20 is 1 times 20. It's also 2 times 10, and it's also 4 times 5. So I have 3 different choices of factor pairs to break the 20 down into. I need to choose the pair that has a perfect square factor. And if there's more than one perfect square factor, you always choose the largest. So I'm looking through these numbers. 1 is a perfect square, but it doesn't change anything to take a 1 out. 20 is not a perfect square. 2 is not a perfect square. 10 is not. 5 is not. 4 is a perfect square. So I know that I want to use this factor pair for my 20. And I'm going to trade my 20 in for 4 times 5 because I know the 4 is a perfect square that will move to the outside. Okay, now scoot over to the x. The x has a power of 5, which is odd. We already talked about on number 12 that in order for an x to move out, it just has to have an even power. So with this odd power of 5, I'm just going to bump 1 away. X to the 5th is the same thing as x to the 4th and 1 more. But the 4, which is even, can move out. So this would move out. Now you can see that these 2 underlined ones will be the ones that move out. And you should also be able to clearly see that the 5 and the x are the 2 that are left behind. So this time I will have stuff that stays under the square root sign. So take the square root of 4, it's 2. The square root of x to the 4th, remember all you do is divide this number, the exponent, in half. So it's a 2. That's what happened when these moved out. What's left on the inside? 5 and x. And this is my answer. All right, one more. This time we have a number on the outside, so the difference will be when we move stuff to the outside to join it, it will multiply with this number that's already out here. So for now, I'm just writing the 5 down. I need to break the 28 down into factor pairs. So I know 28 is 1 times 28, 2 times 14, and 4 times 7. And you're examining this list of numbers to pick out the biggest perfect square that makes an appearance there. And I hope that you recognize this is the factor pair I need to use because 4 is the only number on this list that's a perfect square that can move out and make a difference. So the 28, I'm going to trade it in for a 4 times 7, and I'm going to underline that 4 to remind myself that that's the one that will move out and the 7 will stay in. Scooting over to the x, again I have an odd power. This time I have a 9, so I'm just going to bump 1 away so I can take the 8 even ones out, and this 1 spare one will stay inside. So now I'm taking the square roots of each of these. Don't forget you have this 5 out here, and it's going to multiply anything else that I bring to the outside. So the square root of 4, when it moves out, is 2. The square root of x to the 8th, when I divide that 8 by 2, it's x to the 4th. What's left on the inside is 7 and x. So my final answer, I'm just going to go ahead and do this multiplication. 5 times 2 is 10. And this is my final answer.